Good morning, everyone. In the previous class, we were discussing about different number systems, and we saw how we can represent different number systems. What are the different symbols that are used in those number systems, and which of the numbers are valid in that particular number system. Might be some of the numbers are valid in a particular number system, but might be that is not valid in other one. Okay, so we should know how we can decide how we can write a number system, or how we can represent any number in a particular representation. Okay, once we are able to understand how we can write the numbers, then we need to know, like, suppose I have an information which is written in the decimal number system, and I want to convert it into the different kind of number system. Then how we can do that? So to do that, we have to convert a number system from one number system to another number system. Okay, and this is really very important. So in today's lecture, we will be discussing about, suppose I have a different number systems and I want to convert its base, or I want to convert its radix. Then how it could be done? Because we all know that the decimal number system is the standard kind of number system, okay, that we generally use in the real life examples, right? So whatever the numbers we used to do, like all the informations are physical information that we used to write is in the decimal number systems only. Okay, but the machines, or like system like computers, they do not understand decimal number system. So somehow, or sometimes, we need to convert those information into the binary number system or other things. Okay, so the conversion of number system is equally important. So let us start how we can do that. Suppose I have to convert any number system from another one. So there could be three possibilities, because I just told you the decimal number system is the standard kind of number system. Okay, so the first possibility could be like any other base, the number system, or the information which is present in other base, then I have to convert it into the decimal number system. So this could be the first possibility. This R could be anything. This could be like 2, or it could be like 8, or it could be 16. Depends on which kind of number system we are talking about. If I am talking about a binary number system, like binary to decimal number conversion, in that case, this R will become 2. Okay, and similarly for octal number system, and similarly for hexadecimal number systems. Other than this number system, you can also consider other bases. Like we can also consider base 4, base 5, base 7, whatever we have. Like it is also possible to use your own number system with a different base, not only the base 2, base 8, or base 16. Okay, so this is the first possibility that can be done. The second possibility could be like if I have information in the decimal number system and I have to convert into the other bases. Like other bases could be like binary, or it could be decimal, hexadecimal, or it could be the octal number system. Third is the important kind of possibilities, which is the combination of these two. Okay, what is the combination? Like suppose I have a information, I have a number which is written in the base 1 or base R1, and I have to convert into the base R2, not in the decimal one. Okay, so suppose I have to convert a binary number system to the octal number system. Okay, so in that case, I have to follow the different kind of mechanisms. So these are the three ways how we can convert any number from another number systems. Okay. Yeah, the standard kind of number system, suppose I have, if I'm talking about base R, so the total number of symbols could be like 2 to the power n, and how many bits are involved. So n could be like 1, 2, 3, 4, something like that. And based on that, we can calculate the base will be, if n is equal to 1, in that case, base will be 2. If n is equal to 2, then in that case, base will be 4, 8, 16, and so on. Most commonly used number system is like with base 2, which is a binary number system. Second kind of the common number system is like octal number system, which is here. Okay, having base 8. Another one is with base 16, which is the hexadecimal number system. But yes, of course, we can also have a different kind of number systems as well. Okay, so this is possible. considering all these things, as we know that, as I just told you, the decimal number system is a standard kind of number system. So let us consider the first case. Suppose I have an information, okay, which is available in the decimal number system, or other information which I want to convert. So here we can have a three other. Yeah, I'm just considering the number system which we have just discussed in the previous class. Okay, so we discussed like binary number system, we discussed octal number system, and then we discussed hexadecimal number system. Okay, now if I have to convert binary number system into decimal, or octal into decimal, or hexadecimal number system into the decimal number system, which I am considering the first condition which I have written over here, this one, then how it could be done? Okay, so the first, like suppose I want to convert binary to decimal, or octal to decimal, or hexadecimal to decimal. In that case, what I have to do, I have to consider what is the base of the number which I am converting. Okay, and I have to multiply each decimal digit with the weight of this number. I will tell you in detail more later on. Okay, so the multiplication kind of factor is important here. So I have to consider each digit in the integer and the fractional part, and I have to multiply with the base and its position. Okay, so this is the first kind of thing that could be done. In detail we will see. Okay, the second possibility could be the opposite sense, like decimal to binary number system, or decimal to octal, or decimal to hexadecimal number system. In that case, for the integer part, we have to divide with the ways which we are converting, on which we are converting. Suppose I have a number which is available in the decimal number system, and I want to convert it into the basic binary number system, and we know that the base of binary number system is 2. So the integer part of this decimal number system will be divided by 2, and that will keep dividing until the complete division is not done. Okay, so the division kind of things happens, especially in the integer part. I'm just especially focusing on the integer part, but that conditions changes is if I'm considering the fractional part. Okay, so for the fractional part, that is multiplied. So I will tell you how to do that. But the third case could be like, if I just want to convert from base R1 to base R2, in that case, this is a two-stage process. Directly we cannot, like I just told you, if I have to convert a binary to decimal number system, then I have to multiply with the weight. Okay, and if I have to convert from decimal to any binary number system, then I have to simply divide by the base 2. Okay, but the case 3 is not that much simple. What I have to do, I have to involve decimal number system in this conversion. So what I have to do, from R1 to decimal I have to do, and then decimal to R2 I have to convert. So the third kind of conversion is a two-stage process, which we will see in detail later on. Okay, so this is the third kind of conversion, and this is a not direct conversion. So this is the red one is the direct conversion, this blue one is the direct conversion is possible. But this purple one is direct conversion from binary to hexadecimal number system, or octal to hexadecimal number system is not possible. Yes, this is also possible. Shortcut tricks are also there to do that, but this is not the actual way to convert it. Actually, you have to involve the decimal number system while converting from one to another one. Okay, so you have to involve all those things. Okay, similarly, if you have to convert binary octal to binary number system, then you have to involve the decimal number system here, and similarly for this case as well. Okay, so you have to involve the decimal number system. So let us see how we can do that. Before we start converting the numbers, we should know based on the base. Suppose I have a base R, then the range of the symbol will be like 0 to R minus 1. Suppose I have the base 8, which is the octal number system, so the symbol will be 0 to 7. Okay, so the total symbol, like range of the symbol, will be 0.0 to 7. The base will be R itself only, so it's fine, there is no problem. and the place of integer having n digit is from r0 to rn minus 1. We know that if we can recall the previous lecture where we wrote one formula where we had given some weight on each integer part digits, and similarly to the fractional part. So the range is from r to the power 0 to r to the power n minus 1. This r to the power 0 is close to the decimal point. Okay, this is the close to the decimal point, and this rn minus 1 that moves towards the most left hand side. Okay, so this is towards to the left side, and this is just after the decimal point. R0 is just after the decimal point. Similarly, if I'm talking about the fractional part, then r to the range is r to the power r to the power minus 1 to the r to the power minus n, where this r to the power minus 1 position or the place is closest to the decimal on the right side of the decimal. Okay, so this is the closest one, and this r to the power minus m is the most right hand place in the information whatever we have. Okay, so this is how we can write all those things. Sometimes if we are preparing for the GATE examination, might be we will start preparing next year onwards. So this kind of information is needed, especially where some short trick is important, right? So that is why I'm just highlighting all those things, so that you will be able to crack all those questions immediately, not directly, not just you have to solve in the long way. There is a short trick as well to convert all those things. Okay, so you can do it. Okay, so this is all about the fundamental of number system conversion. So let us start one by one how we can do that. Okay, first kind of number system is like, suppose I just wanted to convert from base r to decimal number system. In this conversion, I just told you we have to consider we have to multiply the base and its weight, its position with the digit whatever we have. Okay, so to do that, this is the simplest formula, okay, which we can consider for the conversion. Okay, so here this di, let us assume, let me write the number, some number like d2, d1, d0 dot d minus 1, d minus 2, and so on. Let us assume this is information which is present in the binary number system. This is a simple example. So what we can do, this di, like simply this part indicate the decimal one, indicate the integer part, and this part indicate the fractional part. Okay, so this is the integer and this is the fractional part, and then accordingly I have to do, like, see, this di is nothing but these digits whatever we have written over here, and this ri is nothing but this is the r is the base and I is the position which we are considering. Okay, so if we are considering the 0th position, then r to the power 0, that will become 1, that will become 1. If I am considering the first position, in that case, like the position of this digit is 1, so we will write here 2 to the power 1, and similarly and so on for other digits as well. So this is all about what we can do for the integer part. Similarly for the fractional part, the position of this one is the minus 1, so what we will write, this number multiplied, or this digit multiplied with 2 to the power minus 1, and so on, and we have to add it, and then that will be converted into the decimal number system. Similarly, if base is other than this binary number system, then we can also do the same. Simply just these numbers, this one and this one will be changed, rest all other thing will be same. Okay, so we are going to change ri and r minus j based on what kind of number system we have. If we have the binary, then this r will be 2. If we have the hexadecimal, then this r will be 16, and for octal it will be 8, and so on. Any other kind of number system we can convert. Okay, so this is the simplest formula that we need to consider, especially while converting any number system. Okay, considering this information, this formula, we have to understand what is the range. The slide is really important. Like sometimes you need these kind of things. So the range of base r number is always from 0 to the r to the power n minus r to the power minus m with base 10. So this is the range of, like suppose you have any number, any with the base r, and you know the number of digit in the integer part and number of digit in the fractional part, then you can calculate what is the range of that number that we can represent in the decimal number system. Okay, suppose I have a simple this kind of like d1 d2 something like some number is there. Let us assume this kind of information is given. Okay, so the range will be like, see here, the total number of digits here is like this value indicates n minus 1, right? So the n will be 2 here. So 10 to the power 2 to 10 to the power minus 2, then you can calculate 0 to 99.99. Okay, so this will be the range. This is how we can calculate the range. Sometimes in GATE exam, one number, 1 mark question can come something like, what is the range for this one? So they used to give like n is equal to this, m is equal to this, and calculate what is the range, something like that. So these questions may be asked, this kind of. Okay, so this is important formula which you can consider. Okay, now let us start converting some numbers. Okay, how we can do that? First number, let us try to convert binary to decimal number system. Okay, so if I have to convert a binary to decimal number system, let us assume consider some number. Okay, so let me change the color. Suppose I have a information which is written something like this, 10101 to the base 2. Suppose this is a number which is written in the binary number system, and I have to convert into the decimal number system. So I just told you what I have to do. I have to first find the places. Okay, so because there is no fractional part, so the most right hand side, the weight will be 0. Next will be 1, 2, 3, and 4. Okay, so these are the position of the bits in the binary number system. If decimal is there, then we have to also write -1, -2, -3, something like that. Okay, so once you have written this placing, then what you have to do, you have to simply use this formula, whatever we have. Let us start from the last one, because I'm considering the base 2 and the fourth position is which is 1. So what I have to do, 1 into 2 to the power 4 plus 0 into 2 to the power 3. Why I'm considering 2 here? This is because this is nothing but this is the base to the power position. Okay, so I have here the information, the base of this information is binary number system. That is why I'm considering 2 here. Okay, so 1 into 2 to the power 4 and so on. Then if we extend this analysis, then it could be like 1 into 2 to the power 2 plus 0 into 2 plus 1 into 2 to the power 0. And if you somehow convert into decimal number systems, and then it will become 16, and this will become 0 plus 4 plus 1. Okay, so this will be the number, like here it will be 21 to the base 10. Okay, so this is how we convert the binary number system into the decimal number system, and this is easily doable. Okay, so you can do it. It's possible that we can do it. Okay, similarly, let us consider one more example, then we can move ahead with that one. Let us assume I have a number something like 1101.101. Okay, so let us assume I have a number something like this. If I have to convert this number into the decimal number system, what I can do, simply I have to place the position. So we know that what is the position? The position of the left hand side will be 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 0 into 2 to the power 1. Yeah, we can directly write it 0. It's not a problem. Plus 1 into 2 to the power 0. Plus, then I have to start from the here only, right? So 1 into 2 to the power -1 plus 0 into 2 to the power minus 2 plus 1 into 2 to the power minus 3. So we can just calculate it and then you will get the number. Okay, so this will become 8 plus 4 plus 1 plus, simply just do it like 1 by 2. Okay, so it will be 0.5 plus 1 by 8. It will be like 1 by 8. So 1 by 8 is like 0.16, something like that. So 0.16. So yeah, just add it and you will get some number. So this is how you can convert into the decimal number system. Okay. So yeah, this is the simple way how we can convert a number system from binary to decimal number system. Similarly, let us try to quickly go through like how we can convert the octal to decimal number system. Yeah, this is quite easy, not that much difficult. So that is easily doable. Let's try to consider one number. Suppose I have a number which is written in the octal number system. Let us assume it is anything 325.1. Okay, let us assume this is a number which is written in the octal number system, and if I have to convert this number into the decimal number system, then what I have to do, I have to simply multiply the bit position with the weight of this one. 3 into 8 to the power 2 plus 2 into 8 to the power 1 plus 5 into 8 to the power 0 plus 1 into 8 to the power minus 1. Okay, and if you try to solve this one, this will be like 3 into 64 plus 2 into 8 plus 5 into 1 plus 1 by 8. So if you calculate all these values, then you will get some value there. Okay, so you can get something, some number, you will get it, right? So I don't need to convert it, you can do it easily. So just after solving this one, you will get some number. Similarly, yeah, so I think I have made it somewhere here and there. So yeah, instead of this one, we can just quickly go through it. Okay, so this is what we can do: 3 into 8 to the power 2 plus 2 into something like that. And if you multiply this thing, then we will get some number, something like that. Similarly, if I have to convert the hexadecimal number system to decimal number system, then suppose let us assume I have a number which is 23ab.d, and we know that this 2 is fine, 3 is fine, but a is nothing but this is equivalent to 10. We know that. And this b is equivalent to 11. Okay, so how we can do that? To do that, we have to simply 2 into 16 to the power 3, because the position is 0, 1, 2, and 3. So 2 into 16 to the power 3, 3 into 16 to the power 2, plus, because a is equivalent to 10, so we have to use a here, 10 here. So 10 into 16 to the power 1 plus 11 into 16 to the power 0. Okay, plus 13. D is nothing but this is equivalent to 13. So we can convert it into the decimal number system. So this is the simplest way how we can do that. So once we will solve it, we'll get some number, something like this one. Okay, now let us talk about till now we just understand how we can write the number system in a standard kind of representation, like binary number system, decimal number system, hexadecimal number system, and the octal number system. But suppose I have other than this number system. Let us assume if r is equal to, let us assume if r is equal to 3. Okay, if r is equal to 3, in that case, can anyone tell me what are the different symbols that are involved in this one, in this number system? Can anyone tell?
0, 1, 2.
0, 1, and 2. Perfect. The symbols will be like, it will start from 0 to r minus 1. So it will be 0, 1, 2. Okay, so this is a representation. Suppose if r is equal to 4, in that the symbol will be 0, 1, 2, and 3. Okay, so this is how we can find the numbers. Now the important thing is we have to do something like what we can do. Suppose I have some information in the decimal number system. Okay, decimal number system. Let us assume decimal number system is 0, 1, 2, 3, 4, 5, something like that. Okay, these are the decimal number system. Now I want to write the number in base 3. Okay, so can anyone tell me what will be the values of all these decimal number system in base 3? How we can do that?
0, 1, 2.
0, 1, 2, then
0, 1,
0, 1, 0 on the left or 0 on the right?
left,
0
1, 0.
on the left? No, it's not like that. See here.
So
How
one-
we can do that is why I just yeah, please tell.
1, 0.
1, 0 will be the number. Yes, perfect. Because the next decimal place will come into the picture. Like,
Yes.
because this is the maximum value which we can accommodate in base 3. And if we are incrementing this value, then the next decimal place will be activated. That next decimal place will come into the picture. So the next number will be 1, 0. Okay, then we'll talk about 1, 1, then 1, 2, and 6, 7, 8, and 9. So for 6, it will be again like, because it will become 1, 2, and this becomes the maximum value. So it will become, what it will become? For 6, can anyone tell what will be the number?
2, 0.
Perfect. It will be 2, 0. Okay, 2, 0, 2, 1, 2, 2, and then what is the number for 9?
1, 0, 0.
1, 0, 0. Perfect. So it will become 1, 0, and 0. Okay, so this is how the decimal places changes after the maximum limit. Okay, so suppose I have information in the decimal number system and I have to convert into the base 3. So I have to consider what is the what are the symbols that are involved in that number system. Okay, so accordingly we can write like this. So this is how we can convert into the other bases as well. Okay, so this is easily doable. That could be done. So, and the objective of this particular thing to explain, like, if I have the number system other than the conventional one, whatever we are discussing, then we have to follow these kind of things. We have to simply first know what are the different symbols that are available in that number system, and based on that we can change the decimal places um, uh, based on the number whatever we have. Okay, so this is how we can do that. Okay, so suppose I have any information which is written in the base 3. Okay, let us assume I have a number which is, let me change the color, 210 into base 3. Okay, and if I have to convert this number into the decimal number system, then what I have to do, I have to simply follow the same kind of procedure what we have done for the octal and the hexadecimal number system. Simply what we have to do, we have to place the position like this will be 0th position, 1st position, and 2nd position. Okay, yeah, it looks like the same, but so yeah, this is the position. So 2 into 3 to the power 2 plus 1 into 3 to the power 1 plus 0 into 3 to the power 0. So 9 into 2, 10, 18 plus 3. Okay, so the number will be 21 in base 10. Okay, so this is how we can represent the number in the different number systems. So this is doable. If in case of any doubt, you can ask the questions. Otherwise, we can move ahead with the second kind of conversion. So if there is no doubt, we can move ahead with the second conversion, which is the decimal to some other base. Okay, till now we understand how we can convert base R to decimal number system, which was very easy. We have to just multiply each digit with its position, its weight, with its position and its weight. Okay, Now, if I have to convert in the opposite way, like from decimal to other number system, then what I have to do? This kind of conversion is a little bit tricky. Okay, how it is tricky? Let us try to understand. Basically, we have to follow the two kind of techniques, two kind of procedure for the integer part and for the fractional part. Okay, so let us directly understand with the example, so that will help us to know that how we can do that. Okay, let us assume I have a number which is, let us assume it is 21.625, and this number is in the decimal number system, and I want to convert this number into the binary number system. How we can do that? Okay, my objective is to convert this number into the binary number system, because this number presents both part, integer as well as the fractional part. So individually we have to process both the parts. Okay, so let us first process the integer part. Okay, the first part could be integer part. How we can do that? Okay, so if I have integer part, so let us see here. The integer part is 21, and I have to convert this integer part into the base 2. Okay, so whatever the number I have, which we have to convert, that we have to write here, and then we have to start dividing with the base which we want. Like we want on in base 2, then we have to start dividing with base 2 here. Okay, so this 2 becomes the divisor, and this 21 is the dividend. Then we have to find the remainder of this one. Okay, so how we can find the remainder? Let us try to see. So if I will divide 21 by 2, then it will become 10, and then some remainder will come. Okay, remainder r will come, and that remainder is 1. Next, if again I try to divide, and this process will be up to we cannot divide it completely. Okay, so then it will become 5, there is no remainder, then it will become 0. Then again we will divide it with the 2, then 2, 1 remainder will come out. Okay, then again we have to divide with 2, then it becomes 1, and then 0, and the last one again I have to divide with 2, and then it is not divisible, and remainder will become 1. Okay, so this is how we can do that. After doing like this, the information bit which are present in the remainder, the first one which we received the remainder, that becomes the least significant bit, and the last one which we received in the remainder, that becomes the most significant bit. Means we have to write this number in opposite order, in this order. Okay, so if we talk about the number 21 which is available in the decimal number system, this will become 10101. Yeah, by default it becomes a similar from the both side, but I have to start from the bottom, MSB, and this will become the binary number system conversion for the integer part. Okay, so this is how we can do that. Now let us talk about the fractional part, how we can do that. Okay, the second part is the fractional one. Okay, the similar kind of concept will be applied. Like suppose I have to convert it into the base 8. So this in place of these two, we will use 8, and then we have to follow the same procedure. And the procedure will be same, just like we did for the binary one. Okay, so let us talk about the fractional part, how we can do that. We know that the fractional part here is like 0.625. Okay, so what I have to do, whatever the number I have, 0.625, I have to multiply this number with the base on which I have to convert, because I have to convert it into the binary number system, and the base of binary number system is 2. So I have to multiply this with 2. Once we have multiplied, then the number will come something like 1.25. Okay, and if some integer part comes, then we'll get it the generated integer. This one becomes the generated integer. Okay, so we'll write it somewhere here. Now the left we have the fractional part is 0.25. Then again I have to multiply with 2. Then it will become 0.5. Okay, and because there is no integer part, so that will become 0. Again, whatever the number I have, 0.5 into 2, then it will become 1.0. And because there is no fractional part left, then this will become 1, 0, 0, and something like that. And then we have to finish it, because the rest next one is 0 into 2, that will become 0 itself. So there is no meaning of that one. Okay, now so whatever the number we have here, because here we do not have any integer or something like that, so we have to write like this. Yes, the important thing is the thing which we did in the integer part, we started writing the number from the MSB to LSB, and we considered the MSB which was generated at the last. The last reminder was considered as a MSB. But here the case is opposite. The first, the generated integer, this will become the MSB for the fractional part. So this is nothing but this is the MSB for the fractional part, and this becomes the LSB for the fractional part. Okay, so this is nothing but this is the generated integer. Okay, so this is the MSB and the LSB. Then if I have to write this number, then how we can write? Okay, so simply we can write something like that, like, so MSB to LSB will be in this direction. So 0.625, which is in the decimal number system, that will be like 0.101 base 2. Okay, and if we try to combine these both numbers, then how it will look like? Suppose I have a number 21.625 into base 10, then this will become 10101.101, and this will be in the binary number system. Now one important question I was expecting you should ask, but no one asked. What happens? Yeah, see here, if we see the fractional part here, after certain stages we are able to get it 0. Okay, but sometimes this may happens, like if this number is not that much good, like if the number is something like 0.6123, something like that. Okay, and you have to calculate the you have to convert it into the binary number system. Then how many stages we have to consider? Okay, because it is possible that it may take long stages to convert into the decimal. Might be it cannot completely convert into the decimal numbers in the binary number system. So you have to consider at least 3 to 4 places. Okay, so that is after decimal 5 values. Yeah, it depends on what you are considering. What is your reference in decimal 5 value means? After 5 decimal points, right? So it depends on what is your application. Yeah, so it depends on your application. Like suppose if you are writing information in the form of byte, okay, then you can consider up to 8, because if you are considering bytes, so the 8-bit information you can accommodate, because that will require a single byte. Okay, so based on your application, you can also consider up to the nibble. For nibble you have the 4 digits. Okay, then you can consider up to 8 digit, then and so on. So this depends on the application. There is no hard and fast rule, but if nothing is asked, then you have to convert at least up to the 4 digit. Okay, so that you can get some nibble kind of things. Okay, so nibble is nothing but the combination of 4 bit. Okay, so that is important, and that you should consider. But there is no hard and fast rule what should be, how many number of digits you should consider. Okay, so this is the way how we convert a number decimal to the some other base r. The similar kind of concept will be applied if you are considering like decimal to octal number system, decimal to hexadecimal number system. So you can do it, just do it at your home, and you will be able to do that, and the similar kind of procedure will be followed. Okay, now let us talk about the third kind of conversion, which is base r1 to base r2 conversion. Okay, in this case what we have to do, as I just told you before, this kind of conversion we cannot do it directly. Okay, this is the two-stage process. Okay, what is the two-stage process? Suppose I have a number which is in the base r1. Okay, then first I have to convert this number into the base 10, which is the decimal number system. Then once you converted this number into the base 10, then you have to convert it into the base r2. So the first stage you have to follow like base r1 to decimal, and then the second one will be decimal to the base r2. So what two different kind of conversion we just saw, that both the conversion will be applied here. Okay, so we saw like base r1 to decimal, then decimal to base r1 or base r, then both kind of concept will be applied here. So we can say this kind of conversion is the two-stage process. Okay, that we can do that. Let us take some example. Okay, let us take some example how we can convert it. Suppose I have a number with some other base. Let us assume 231 in base 4. Can anyone tell, is this the valid number system representation? Is this valid?
Yes, sir.
Perfect. Why?
So because till 3 it is valid, for base 4 I think.
Yes, perfect. So the range of the symbols will be from 0 to 3. So 0, 1, 2, 3. So this number is valid. And I have to, let us assume, I have to convert this number into base 5. Let us assume any number. Okay. Let us, I have number 231. I have to convert into this one. So what are the process? Just in the previous slide, what we just saw, suppose I have like some other base and I have to convert into the decimal number system, then we have to follow the simple thing, like what we do, like just multiply the each bit positions, and then we can do that. So to do that, let us try to do, it will be like 231 into 4, that we can write 2 into, because base is 4 to the power 2 plus 3 into 4 to the power 1 plus 1 into 4 to the power 0, and this number will become in the decimal number system. Okay, so this is what you can do that. If you try to solve it, 16 into 2, 32. So that will become 32 plus 12 plus 1. So 55. Okay, so this will become the 55 in base 10. Now once you know this 55, then I have to convert into base 5. Then what I have to do?
45 I think.
Sorry, yeah, 45. Yeah, 45. And then I have to convert this 45 into the base 5. Then what I have to, simply 45, then start dividing with the base which we want, and we want in base 5. So I have to start dividing with 5. So the 9 will come, there is no reminder. Okay, and then the next will be, again I have to divide with 5. So 5 ones are 5, remainder 4 will come, and then simply, like, again I have to divide with 5, 0, and this one will become will come over here. Okay, and I have to simply from MSB to LSB I have to write, so that the number system number representation will be, the final number representation will be like 140. Yeah, from here to here, so 140 into base 5. Okay, so this will be the final number system representation. 231 into base 4 is same as the 140 in the base 5. So this kind of conversion you can do it easily whenever you want.